My name is Elaine Petro. I am supporting this project as a research consultant for the Space Infrastructure Laboratory based in Ithaca, New York. My role in the SPAR project is to lead the electric propulsion modeling team. So we're a team represented by 4 different labs and 1 industry partner, and we're all working together to understand how the plasma thrusters operate under new conditions with new propellants. In this project, we have a few objectives that we hope to accomplish. One is to develop models, fundamental models of the chemistry that's occurring inside the device so that you can understand how the device converts electrical power to thrust. And the magic of that energy conversion is in the chemistry, so we're really thinking fundamentally about how the particles exchange energy. So that's one objective. And then the other objectives are to integrate many different capabilities that already exist in different fields and bring them together so they're all supporting the technology that we're studying here. So we may have the ability to understand how a plasma interacts with a surface in another context, so we now need to import that capability to being able to model the surfaces of the Hall thruster, for example. In the next year or so, the project is really kicking into the next gear in terms of testing. So there's a very ambitious test schedule, and our job as a modeling team is to be able to help them interpret those tests. So that means we need to be able to simulate the conditions that they're testing. And while the models in theory allow you to explore a wider parameter space than you can with tests, that means that you have to have all the functionality there and all of the chemistry modeled. So it's actually going to take us a little bit of time to catch up to what they can run experimentally, because it's actually a lot easier to just throw a new gas into the thruster and see how it performs than it is for us to throw a new gas into our model, because we have to know sort of like everything about the gas and how the energy is exchanged between the atomic and even subatomic particles in the gas. So our efforts in year 2 are really focused on doing the best we can to assimilate the knowledge that's out there about the chemistry that's relevant. Our work will benefit the USSF broadly because the SPAR program is targeting some really ambitious new operating regimes for these propulsion systems that have been around since the dawn of the space age, and they've really just been using one propellant and operating in a certain sort of narrow range. So what SPAR is hoping to do is to push these new propellants, which could be cheaper, more accessible, more flexible in their use, and make our thrusters more powerful than they have been before. So that means your spacecraft can move faster, it can stay aloft for longer, it can do things that it couldn't do before with a sort of more limited propulsion system. So it all, this program tries to bring together all of the different technologies that you would need to realize that on orbit. And us, particularly focused on the modeling, we hope that we can really, help, when you find that the thruster isn't operating like you want it to, we can help the team understand how to tweak the performance to make it acceptable.